Okay, hello students. This is Unit Algebra 2, Unit 5, lesson number 10, and this is about combining functions. It means you'll be given two graphs and you may want to add them or subtract this. So the students facing the goal is let's make some new functions using other functions. I can combine two functions in different ways. So directly let me go to the practice problems, and here is. So the first question is sketch the graph of the function defined by sum. That means you are given two graphs. You see this. So what you're supposed to do is create a sum of the function f, and the other one is ax. So you're supposed to add this to f, sum of the function f and each of these functions. So in each case you are given a and f, b and f. In this case, so you have given the f of x, that is exponential. Let me go directly the. So this is the first problem, and you can see the exponential function. This is the exponential function which is given. So this is the graph that is given to us. So this is the given graph, and the other one is a line. So that's like always ax. So it's a line where it is y is to. I wanted to write this in your paper. So that means every time you are adding 3. So this is 3. Now I'm gonna take this off. Hmm. So to f of x, so this f of x, we are adding uh, 3 each time. So that means if this is the point right here, this this is 2. So the y-intercept, this y-intercept is 1 here, and this is 3. 1 plus 3 is 4. So your point will be when you add this, you get that point. This point is 1 point. This is at 1.5 is 3. This is 3. So you can add 3 plus 3. Let me use the green color. So this place where both are having the same y coordinate. So it is this 3 of the f of x. This is 3. At this point it is 3, and this also is 3. So it goes to 6. So this point stretches up like this, goes up. When it is 1, I'm going to use maybe this color 1, this one. At, so the the exponential y input is 2. This is 2. 2 plus 3 becomes 5. So this will become 5 right here. So this is how your point. And at 2, 2 is exponential function is 4 here. So this 4 and 3 will give you 7. So all the way here, this goes up here. And then if it is, let's see, if it is minus 1, if this is minus 1, so this will move. So it will be 3 is added to this 0.5. So this is 0.5 right here is 0.5, and you're adding 3. So that will be 3 and something. So that will be 3 and some, 3.5 here, somewhere here. Now let me take this off. The point will be somewhere here. And now each time these points are little above this, somewhere here. See this is a little above small positive number. That means this graph will be very small here, little above. So they go on almost becoming equal to the line, the 3. So and you get a new graph will be, so this will be your new graph, and something like stretches like. So hope that helps. Let's go to the next one. Now in this case, again we have the same exponential graph f of x, and this time you're adding this line bx. So let's start with let's say start with this one is 1 here. This is 0. So this will be, so the line goes, this line goes through the origin. So that's why coordinate is 0. So that's 0 and this one will be the same thing, 1. At this point, at 1, this will be the y 1. And here, this is 2. So 2 plus 1 will give you 3. So this point will go like this. At 3, at 2, this is 2. And this is 4. And 2 plus 4 is 6. So that point will go up like this. And then let's take somewhere here. The minus 1 is minus 1. This is half here. So that will go uh, half and minus 1. So this is minus 1. So that will be minus half. So this will be point like this. And because these points are little above positive, so they are almost going, if you add to this output, so it will be almost the same line. So you see. So they will be always the same line and it will go something like this. So we are going to get a graph like this. And then almost touching this line. And that's it. So that's the second one. Okay, in this case, there is a parabola through this. So let's start with this point. This is 0, and that is 1. So this point will stay the same because you're adding a 0 here. Now let's take this at 2. So 2 is 1, and here it is 4. So 4 and 1 together become 5. So that will be 5 here. Now this is at this point at 1 and little, this point is little above, so it will be 2 and something, so it's something like this. And then and we go to the left side, if I take a minus 1, it's like both are almost like point 0.5, zero point 0.5, a little 1 for maybe somewhere here. And then as you go to the left, these numbers are positive, but they are becoming very small. So it's almost going to be the same output for this. Doesn't affect much. So they will be like this, going this way. And your new graph will be, so your new graph will be something, something like this. Okay. It will go through this and then almost closing like this. So that takes care of that one. What about here? And you will see here in this case, any point you take this here, this is 2 and 4, right? And if you see this point, it is 2 and minus 4. So write down this on your paper so that 2, 4, so you are adding f of x, you are adding to d of x. So when you add this, sorry, you are adding this. So adding 4 plus minus 4, and you get 0. So each time you will see this point will be here, and you can take this point and this point, you add them, you get this point. So basically you get a line y-axis. The new function will be a line. Here there are two graphs, f and g. F is like a parabola, and the other one is a line, right? So you are defining h of x is, so h of x is f of x minus gx. So you are subtracting this one, f of x graph, to gx graph, this one. Now for which values of x is h of x is 0. Now what that means is the only way this could be 0 is both should be the same. So please write this, f of x has to be gx. That means both outputs should be the same output. And the only way they are is where they cross each other. So this is where they cross each other. These are the 2 points. So you can see this is at, so the answer is 1 is when x equals minus 2, and also when x equals, so these are the 2 places where the graph crosses. Yeah. The second question is for which x is each x is negative. Now, what is this negative means? When you subtract, you get a negative answer. So like this one, if you subtract, this is 0. And the only way you can get a negative is the f of x. So f of x will be this output has to be smaller than g of x. So you have to see where is the graph uh, uh, less than gx. So you can see this is the graph, and I'm gonna do this. Gx is this part. See, it's above. It means that this y coordinate are bigger, and the down one, and this is below. See, so here f of x is down, and the red g of x that's above. So when you subtract f of x minus gx, you're going to end up getting 0. So the answer for this part is from -2 all the way to 0. So you're supposed to write -2 less less than x. So you write less than x and until 0. The second question is when is hx positive? That means the other side, let's say f of x. So this is black color is up here, okay, and the red one is down here. So you can clearly see that this anywhere, if I try to draw anywhere like this, see like this, anywhere that point, so this point will be up and this point is down. So this y output will be greater than the down one. So that means you can see from the left side for which, so it's happening on the left side. So here also the black color f of x is up and the blue is the red is down. So this line say, so this red is down now. So that is all the way from left side. So from -3, or you can say you see this graph to what we see here is it will be. So for this part, this from -3 to 2. So this is for, so we want to know on this part h of x. So h of x is greater than 0 when in -3 less than x less than -2. So here you see on the black graph, this black graph is up. So because it is up, the output becomes bigger than this graph, the line, the red line there. And also if you see the other side also, uh, on the right side, you'll see the black graph is above. So we say, okay, from 0 less than x less than 2. So this part. So from here to here and also from here to here, the black graph is above. Okay, and when you subtract, you'll get positive. That's what the question was. When is f of x is greater than g of x based on this part? And I hope that takes care. Now the original function of square function, the graph is square function. Original function is like this. See, this is the original function, which is square, just a square. This one. Now the question is asked, what is this? Now this means you can compare with x minus h, the whole square plus 0. That means the h here is, so the h is 0, sorry, h is 1, you can see this is that 1, and that means and k is 0. So where is 1 and 0? So you see that k is 1 here. This graph is 1, which is the coordinate is 1 comma 0. So this graph gets shifted 1 unit to the right. So or the original graph shift, uh, first the original graph shift. So this is the one which goes here, and then that's it. That's all they're asking you. This graph which you see here, this See, it was here, right? So now shift 1. Because of that, h is 1, so it moves one place. Or you can also remember, if there is a -1 here, it means the graph shift one place to the right. The next one is what's happening once you do, if you see here, there is a +5. So what it does is the same graph first, this graph shift here, and then there's a +5. So it has to go maybe 1, 2, 3, 4, and 5. That's it. So this point is 1, comma 5. So this point is 1, comma 5. So that's the second part. Right? And the third part is there's a minus. What does that minus do? So this minus is, now this part we have to be very careful. There's a minus here. So what our option is, the black graph that you see is first there is a -1, right? So the what I'm going to do is first is you shift the graph to the right like this, and then we can reflect this graph. Watch this. So there's a minus sign here. So what does this mean? The black graph gets reflected over the x-axis. So if I can keep like this, and I can flip, see? So this graph gets reflected here first. And after that, there is a +5, and then it goes 1, sorry, this one, 2, 3, 4, and 5. So this is the graph of the bottom one. So be careful here when there's a minus. You first do the inside, that is -1 means it goes to the right. Okay, so it goes to the right. So so how did we get this is, if this is the original graph, then it reflects over the x-axis. Then it moves one unit to the right, and then it goes 1, 2, 3, 4, and 5. So this is the final answer. So this graph, so this is the graph for that. This is question number 4. The table shows the approximate United States population and the amount of sugar consumed in given year. Now see, so 5 million population consumes 30, 23 million population consume 460. So this is given, this is like in 19, maybe in the year. So they gave you this is like in the year 1800, and then this is 1850. This is 1900, this is 1950, and that is 200. So every 50, 50 years. And you can see there, you are given a grid also with 50 there. And we need to figure out how many pounds of sugar per year were consumed by each person. Now this is by 5, right? 5 million population, and this is 30. So all you're doing is, in 1800, you do 30 million divided by 5 million, and you get answer as 6. And likewise, you do this, if you divide this, that answer will give you, you can use a calculator also, or you can clearly see it is nothing but gives you 20 times. So this, when you divide 23 and 46, double, right? So that's 20. So if you divide this 3000 divided by 76, you get 40. You can check that. 12,000 divided by 61 gives you 75. And if you divide this, you get 110. So that's how you do. And then you plot these points. So that means, so when was 1800, it was 6. So this point will go, 6 will be somewhere here. And it is 50 will be 20. So if it is 50, will be 20 here. And then 100 is 40. So this will be when you divide this. So that's 40, right? So this will be 40. And then 150 is almost like 75, which is below 80, somewhere here. And then the last one is 200 is so the 200 is 110. So I think I missed that 110. So when you divide this, okay, I already got this. 110 will be here halfway down. And you're done. That's all you're supposed to do. So the basically is to understand how much is the you have to find the ratio to find how many pounds of sugar per year were consumed by each person. So you have to divide this. So 30 million pound divided by 5 million population will be that's like 6, and that so 6 pounds per person. So that's what it is. So this 6 basically means 6 pounds per person. Here is a graph of the function, and use the graph to explain why this function is neither odd or even. Now the graph that you see, if I want question is it even function? Now how do we know if it is even? Is you have to reflect over the y-axis. So if I reflect this graph, this graph will look something like so this point will be somewhere here, this point will be somewhere here, and it goes. So this will go something like this, see, and you don't get the same graph, so it is not even. And this, so question is it even? Is it odd? Now to check whether it is odd, if I reflect, it will go first this way, okay? And when you reflect over the first reflection over the y-axis gives you this, and the reflection over the x-axis will give you something down. So this is not the graph of that. So this is how you can see by graphically, you know that this is not neither even nor odd. Now, how about you are given an equation? Another way to show whether this is not even is, if you see even is this point. Let's say this point that you see is 2 comma 0. Now this point, when you reflect, it goes right here. See? So when you reflect, that this is not part of the graph. So for the function, for the graph to be even, if I reflect, that also should be the point on the graph. So it means f of minus x, this one should be same as f of x. So for the opposite output, the input should be the opposite input, the output is the should be the same. But here you see this point is not part of the graph at all. Now the second is an equation is given. So they gave us the equation here of the graph. Using this equation, how do you know it is neither odd or odd? Now, so the two things are happening. To know whether it is even, we need to replace x and minus x and see whether f of minus x is same as f of x. So if I put f of minus x, you get minus x, the whole square minus 2 times minus. So that is minus x the whole square becomes x squared, and this becomes plus x. If you see, this is not f of x. So that's why this the the definition of odd even function f of minus x is this fails. So this fails. So not now. How do you know whether it is odd? Is so for the odd it should be minus of f of minus x should be equal to f of x. Means reflecting over the x. So that one thing is you just look at it and then but how do you show here this part? Now that you got this is this equation, and let me take the opposite of that. So this will be minus of x squared plus x, okay? Because we already worked out f of minus x here. It is right here. So what all I do is I paste it here instead of f of minus, and you get minus x square, and minus x. And you can see this function which is here, this is not the same as x square minus 2x. So this is how you show algebraically that this is also not odd. Okay, so I want you to read this question because this is the same problem we did long back. I tried to explain. So there is a function. This f to represent the height of a student on the Ferris wheel. T seconds after her descent. That means in the beginning she's on the top of that Ferris wheel, and it clearly shows that's the height of the Ferris where she begins. So with the 0 time she's on the top of the ferry, and then she goes down, and the height goes on going down. So after 5 seconds, 181, 10 seconds is 106, 15 seconds is 31, and so on. So she goes back to, so what basically this means is so uh, it means there is a ferry. Let me do it right here. Maybe I'll try. Okay, so if I use, let's see, this is like a, okay, XX. This is like, let me x-axis and the y-axis. And the Ferris wheel, this is, let me mark, this is where she starts, 212. So that's 200 and, so that's 212, okay? That means half will be 106. And then 181 will be somewhere maybe here. And 31 will be somewhere here. And I can use, okay, this is like 20 seconds. This is 10. And this is 5. And this is 15. So in the beginning, she is at this point. So let me graph. So that's where in 5 seconds, this is the height, 181. In 10 seconds, half, 15 is 30. So kind of, so let's check this visual, and you can graph this also. So it's something like this. And in 20, it is back to 0 here. So this is, so what's happening is, all you do is, the one that is given is information about one of the ferry, but then she visits two more ferries. Another ferry that is whose height is half the height of the same speed. So it is going down. So both, this is going down, but it, the height becomes half. That means the speed stays the same. It's after 5 seconds. This point, which is right here, this stays the same. This will go here. So this point, which is right here, which was, I think, 106 will be 53. 53 will be, this is 31, and 53 will be somewhere here. So everything goes half. So I'm sorry. I mean, so this was 212. Now the height becomes here. This is where the height is. So after 20 seconds, she reaches home, back to home, but all the heights will become half. So this becomes 181. Half of this will be 90.5. This half of this will be 53, and this will be 15.5, and you're back here. So this point will go. She starts here. This point will go half, which is 90.5. Maybe here. This is 31. And then this point will go here, so somewhere here. So something like this. Not perfect, but just wanted to show graphically also that all this height they become half 15. So 15 will be somewhere here. So this point will be somewhere here. Now the next is the, so let me take this up and use a nice one. So as I said, this was 212. Then half was here, 106. That was 81. Now the next question is, at the same time, you must write this PT is half of FT. That's it, and you're done. The next one is what's saying is he goes to another Ferris wheel where the speed is twice, so the time taken will be half. So what that means is he starts with 200 and height. So he starts with 212. So he starts here. Okay, let me draw the original one. This was the original. She reaches in 20 second in 10. So if it is 10 was here, 5 was 81, and 15 was like, so your original graph was, this was the original graph, okay? And now because it's going speed with the uh, twice the speed, so 212 starts that point, and now instead of 20 seconds, it will reach in 10 seconds. So it will reach 5 seconds only, it reaches back home here, 0. So this will be 0 here. And in 5 seconds, it will be the same as what it was 10 seconds. So 10 seconds was 106. So this become 106. And that's how you figure out that, okay, so this is done. The question is why we cannot find. So let's graph this. So it starts with this point that stays the same. This stays the same, and this means when after 5 seconds it is 106. So the 106 is somewhere here. So your graph is new graph, new graph is like something like this, and she reaches back home. See, these are the only points. But the question is, why do we not know? Why can't we find this? 15 seconds. So this is 15 seconds. Can we do this 15 second? But but the original one they didn't give us. So what this is, you want to find R of 15. Remember, R of 15 is same as the original F of 30 because this Ferris wheel is going twice faster. So it takes half of whatever the original one. So here it is F of 30 here. So but then we don't know, in this case, we don't know what is f of 30. So this part is not given to you. So you're not given what was the height when it was 30, 30 second pass. We don't know. And the same thing here, 20, f of r of 20 is same as f of 40 because r takes half of whatever f. And we don't know what is f of 40. So there is no f of 40 here. And that's why we cannot figure out that part. So I hope that helps. And with that, it ends the question lesson 10. And now I'll do next one is lesson number 11. Thank you for watching. Make sure you write down all this. And what you're supposed to write is at the end is, I think I forgot, is you're supposed to write F, the new one, R of t is, so the time taken, the height at any time is always the F of twice the t. See? So it means that it can be written as F of t over half. Okay, so there is a horizontal, shrink by scale factor c equals half. See, and this is less than 1, so there is a horizontal shrink. Hope that helps. Thank you so much.